fractions. And I know that sounds really weird. So let's do some background on what we're going to be doing. And this does involve systems of equations, so that's why it's kind of in this mix with all our other Unit 5 systems of equations. So if I were taking two fractions and I wanted to add them or subtract them, well, the first thing I would need is a common denominator. So the common denominator would have both x minus 4 and x plus 2. So for this equation, I need to multiply by x plus 2, or this fraction, numerator and denominator. And then I need to do the same thing over here. So 3 over x minus 4. I'm going to multiply the numerator and denominator by x plus 2. On the other fraction, it has the x plus 2. It needs an x minus 4. So now they have basically the same denominator. So I'm going to be taking 3 times x plus 2 minus 2 times x minus 4 all over x minus 4 times x plus 2. And when I simplify that out, let me distribute. So that would be 3x plus 6, then distribute here, negative 2x plus 8 over x minus 4 times x plus 2. Simplify even further, that's x plus 14. What we're going to be doing in this lesson is taking an answer like this, where it has more than one thing in the denominator, and then working backwards to split it up. Interesting, huh? Okay, so how about let's actually just take that one and work through how to split it up. Okay, so x plus 14 over x minus 4 times x plus 2. Well, I know that had to have been, we actually know what it was, but it had to have been something over x minus 4 plus something over x plus 2, right? Well, let's think about how that ended up happening. We would have had to multiply this by x plus 2 and x plus 2, right? Whatever that was. And this fraction I would need to multiply by x minus 4 and x minus 4. Now everything has the same denominator. So what that really tells me is that x plus 14 is the result of taking a times x plus 2 plus b times x minus 4. Let me distribute. ax plus 2a plus bx minus 4b. Now what I want you to notice here is the parts that have the x with them and then the others don't have an x. So I'm going to split those up into two things. 1x equals ax plus bx. In other words, 1 would equal a plus b, right? Okay. The others that don't have an x, I have a 14, 2a, and negative 4b. So in other words, 14 has to be the result of adding 2a and negative 4b. What I have is a system. I'm going to rewrite it as a plus b equals 1 and 2a minus 4b equals 14. So I just kind of rearranged which side they are. So I end up with this system. These were the coefficients of x equals the coefficient of x. And these were the constants, for lack of a better term. But we have these two unknowns and two equations. So we can solve these. I think I'm going to multiply the first one by 4, so times 4, and get 4a plus 4b equals 4, and leave this one just like it is. When I add these together, I get 6a equals 18, because the b's would cancel, so a is 3. Now, a plus b was 1, so 3 plus what is 1? B is negative 2. Let's see if we got it right. A and b. So minus 2 is the same as adding a negative 2. So we have deconstructed it into 3 over, so this was a, x minus 4, plus a negative 2 over, that was x plus 2. We got back what we started with. Now, the next one is going to be a little different. X minus 18 over x parentheses x minus 3 squared. So because I have this term squared, it's going to break down a little differently. I've still got the x, so I've got a over x. The next one is going to be b over x minus 3. That gets one of these. But for it to be like a common denominator, I really end up with needing c over x minus 3 squared. So whenever you have a repeated factor, it's going to go in as a single and as many times as I need to get up to the exponent. Now, thinking through what's going to happen to each of these, this a, we have x down there, so it needs x minus 3 squared, top and bottom. This one needs an x and an x minus 3. And this one just needs an x. Now the denominators are all going to be the same, so I'm going to kind of skip that step. And I'm going to have x minus 18 is going to equal a times x minus 3 squared plus bx times x minus 3 plus cx. Okay, I need to simplify this. So x minus 3 squared, x minus 3 times x minus 3, that's going to give me x squared minus 6x plus 9. Distribute the bx, and we get bx squared minus 3bx plus cx. Distribute the a. Oh, not a. Okay, so I want you to notice a couple of things. The first thing I want you to notice are these x squareds. But there's no x squared over here. So ax squared plus bx squared is going to give me 0x squareds. In other words, a plus b is 0. The next thing I want to look at are the ones with the x's. So I'm going to change color. This one has an x. This one has an x. Ooh, this one has an x too. And this is an x. Okay, so I've got negative 6ax minus 3bx plus cx equals x, equals the x over there. So in other words, negative 6a minus 3b plus c equals 1, because I'm looking at the coefficients. Got one more to go. Negative 18 on this side, and this is the only constant I have over here on the right. Constant, for lack of better words, because it does not have a variable with it. So that gives me 9a equals negative 18. Oh, that's nice. Why do I think that's super, super nice? Well, I can actually solve that. I can get a is negative 2. Then I can look at this equation. A plus b is 0. A plus b is 0, so b is 2. Now I can go to the second equation. Negative 6 times a minus 3 times b plus c is 1. 12 minus 6, that gives me a 6 plus c equals 1. So c is negative 5. So my deconstruction of this turns into, see, we had a over x, so negative 2 over x plus b over x minus 3, so b over x minus 3 plus c over x minus 3 squared. Example 3. So this would be made up of a over x minus 2. I do not have any repeated, so I don't have to worry about the repeating part. To get this to have a common denominator, I would have to multiply the top and the bottom by x squared plus 2x plus 4, and this one by x minus 2. Once you kind of get the hang of it, you're really multiplying by the other denominator. So this is going to be a times x squared plus 2x plus 4, and then b times x minus 2. Distribute. match up the like terms. So I've got bx squareds. So that means a equals 3. That's nice. Uh-oh. Except for I just made a mistake. Sometimes that happens. When there is an x squared term, it means that this could be linear. In other words, something x plus c. If this had been an x cubed, this could be an x squared. So I apologize for making that mistake. It does happen sometimes. I started looking at it and I was like, something doesn't look right. And that's what it was. I was missing something. The rest of it still is basically the same process. But instead of that just being a b, it's bx plus c. So I'm going to have all of bx plus c times that other denominator x minus 2. So we'll have to distribute there. It's a little bit more on the simplifying part. But I knew I was missing something. So this will be ax squared plus 2ax plus 4a. And then over here I've got to distribute. So I'm going to be doing basically the FOIL method. So bx times x is bx squared. Then outer would be negative 2bx. Then c times x would be cx. And then c times negative 2 is negative 2c. That's better. I knew I made a mistake. And I'm totally willing to tell you when I made a mistake. The x squared terms. Aha, that's where I messed up. See, I do have another x squared term. So ax squared plus bx squared is 3x squared. In other words, a plus b is 3. Next, I want to look at the x's. X, this just has an x, this has an x, and this has an x. So 2ax minus 2bx plus cx equals 17x. In other words, 2a minus 2b plus c equals 17. Now I've got the constants, the ones that don't have a variable. And that one gives me 4a, minus 2c equals 14. So I need to solve this system. Well, we have something interesting here because this one doesn't have a C and this one doesn't have a B. So I'm going to add these two together to get rid of C. So I would need to do, so here's equation 1, 2, 3. I'm going to do 2 times equation 2, make that a 2C, and add it with equation 3. So 2 times equation 2 would give me 4a minus 4b plus 2c equals 34. Then I'm going to take equation 3. And I'm going to add those together. Now I'll have a 4b here, but I'm okay with that because equation 1 has an a and a b. So what if I took equation 1 and multiplied it by 4? So 4 times equation 1. That would give me 4a plus 4b equals 12. What if I add those together? I end up getting A is 5. Well, I know that A plus B is 3, so 5 plus B is 3, so B is negative 2. Now I'm going to go to that middle equation. Well, I could do that, or I could go to the equation 3. Let's go to equation 3. It's easier. 4A minus 2C is 14. So 4 times 5 is 20. So negative 2C equals, what's negative 6? C is 3. Wow. Okay, so my decomposition is going to be A over x minus 2. So 5 over x minus 2 plus bx plus c. So negative 2x plus 3 over x squared plus 2x plus 4. And that is just kind of a glimpse of how to do these partial fractions.